Aloha, Richard Halverson here. This is ICS321, and this is the third week of the semester. And so today we are in chapter 2. We covered up to chapter 2.1 last time. And so today I'm just going to continue with that. And we do have 2 class sessions this week, so I'll come up with some interesting stuff for Friday, probably more on the assignments. But so let me share my screen. And I'm going to go through the same routine that I go through every time, just so you, because it's a good practice for you also. Here we are. If you look at the syllabus, we are in week 3. So I like to September 8th. So I like to keep my videos like around this what it says here, and so as you are doing the textbook, you're gonna just know that it's probably covered someplace in a video, and so what I'm going to do now is what I do before class every semester or every day, and that's I go to the last video and I go to the very end and I look up at the top here and I see the section that I'm in at the end. See, now the only reason I tell you this is the trick is to look at the top to see the section. So if you're ever working on stuff and you go, God, you're doing a challenge activity or something and you don't get it, well, you can just go to the video, and I try to have some description down here in the title of the video. But that way, just that's kind of the way to zone in on what you might need. It's it's right up here at the top. So all right, so that's why I know 2.1 was the last one that I did. Yeah. Okay, another thing I wanted to point out, I haven't kept up with your forum questions. But I will by next time. This is a relatively new thing I'm doing, and it's pretty helpful in my other classes, which are more elementary programming, and the questions are a lot more interesting, a lot more basic. Anyway, so keep on going here, but I did, it has come up, how do I know that you're completing these things? And the way I know is that when I log into the book, over here on the right, I can click on reporting. I'm sharing my screen. And then this is how I can download all of your scores. See, so what I do is I just click all the check boxes for all the chapters that we are, and that way I catch everybody who's working ahead. And there's always, in a class this big, there's about 5 of you that are probably done already, and that's cool. Okay, all that means is that I can't change something once you guys have started. But it's good that they're people like that, get it out of the way. But then there's also people who fall behind for whatever reason, like they have a life. And so whenever I do this, I download all the scores, even if it's like later in the semester, I'll catch updates, or for those of you that are falling behind but have caught up. This is the percentage of students in the class who have completed these things. So, see where, and then I click on download report, and I get this big, huge spreadsheet, which I'm not gonna, I better not show anybody. Okay, good. Okay. So I saved this. I'm going to cancel this, and it's got everybody's individual score, and then I process that and pop it right into the Laulima gradebook, all nice and lined up and everything. To do the gradebook thing, I download the existing gradebook and paste these scores in and upload them, and then you'll see them here. So you don't have to do anything. You don't have to do anything. Not anything at all, except for I want you to know, I want you to make sure that by this day, you know, that you have everything done. Okay. And I won't even know if you finished everything, you know, 2 days before, but of course you don't want to wait till the last minute. It gets frustrating clicking through the participation exercises, the participation activities, which you got to click through because you want to get the points. But you feel kind of like you're cheating because you're just like clicking for the answer. So don't end up having to do that. All right, so let's get going with chapter 2, starting with 2.1. Let me just pop open here. I did want to mention, okay, so they make me do this participation thing where I have to put in people that haven't participated, and so there's always people that get put on that list that don't want to participate, or that of course are going to participate. They just haven't purchased the textbook yet, or whatever. You know, all you got to do is email me back and say, yes, I want to participate, because I need some kind of response to know. And the reason is because if in the very end I should end up having to give you an incomplete /F or anything that has an F in it, anything below a D-, then I have to put a date for the last date of participation. And if I put a date, and if I don't have a date, then I put in the date for the first day of the semester, and then I get in trouble because that means I didn't identify you in this stage. So I think that a lot of that is to check up on instructors paying attention to students. So, but if you email me, then that's the last time I had an interaction with you. So I would put that date in if I never heard from you again. But you know, don't be one of those students. All right, so we have finished. We're just getting started with all of the fun stuff with relational databases here. We did have a good introduction to everything that we're going to be doing in chapter 1, and so let's start out with section 2.2, because we just finished section 2.1 here, where we talked about all the different database models, relational models, getting motivated for what's sort of coming up here. So in databases, as you probably know, we have tables, and tables have columns, and tables also have rows, and the intersection of a column and a row is a cell. And so we can have such thing. Okay, so these columns, of course, have names, and so the concept of an empty table is simply a table with defined columns but no rows. You know, so it's the table itself is defined by its columns. So that's pretty straightforward. You should click through this to see what we mean by that. There's you know, column names follow the same sort of rules pretty much usually as variable names in programming languages, but you know, not really, because you can do something like well, you can have spaces, but when you use spaces, you have to enclose the column name in backticks, and then they can be seen. So, and I wouldn't recommend that because it's kind of humbug. I would recommend, of course, if you want spaces in your column names, to use underscores. So now columns have data types, just like variables in programming languages have data types, but they can be a lot more strict in databases. And what's nice about databases is that it enforces it. It doesn't let you put anything in the column of a row that you're inserting into the database, into a table. It doesn't let you put the wrong kind of data type. If it's supposed to be an integer, it doesn't let you put any letters or numbers in there. So it gets pretty specific, as you can see. So in general, these are the different kinds of data types, but there's lots of different types for each one of these categories also. And if we look in our actual, I've logged in someplace. Okay, so I've logged into my cPanel here. And if you look into, once you've created a database, you can look into one of these tables, and you can see that. Let's look at one of these tables for horse. We see that if we look at the structure of this table, we see these are some different data types for these different column names. And if we were to want to come along and change one of the data types, we would have a large choice of types. And if I were to change this, let's say it says registered name, and so there's a name here. And let's say I were to want to change this to an integer, okay? However, in registered name, there's a bunch of records that aren't integers, then it just won't let me do it. Okay? It will not let you do something that'll violate the integrity of the database. So anyway, we were in chapter, okay, so that's section 2.2, different data types. Here, you want to match up what these different types are with examples here, just so you understand. This is a date, of course. And character, binary, and so on. Okay, then there's a lot of, then there are these structural rules regarding just tables in general. And tables are normalized. First normal form, they're normalized if these three rules are held. Tables are normalized. Okay, anyway, there can be no duplicate column names. Duplicate column names are not allowed in one table. However, the same column name can appear in different tables. That's no problem. And duplicate rows. You cannot. There can't be two rows in a table that have exactly the same values all the way across, because that's duplicate rows. So you can't. Okay, so that's the first. Now it turns out that our databases in our here, they can actually hold tables that don't follow the multiple rows rule. Okay, and there's actually a name for those kinds of tables, and they're useful in databases and advanced databases, and I think they're called bags and not tables. No, instead of being called relations, they're called bags. But anyway, we aren't getting into any of that. But you can't have more than one one value per cell, so you can't have somebody like that. You can't have two, and you can't have two columns with the same name, and you cannot have two rows that are duplicates. Now, when we get into actually making databases in MySQL and so on, there's all kinds of times when you can produce exactly this, and you can produce exactly this, so those are all things that are not tables that are not normalized, and you have to do. You have to be cognizant of the fact that you want normalized tables. So you have to do things like use the distinct prefix when you're identifying the columns that you want displayed and so on, and that'll make sure that your tables end up being normalized all the time. So make sure you understand all these, answer these. Null values is kind of an awkward thing, but we want to have null values in our tables. And we're never really sure if a null there is not really, null is there because we don't know what the value is. This thing should have a value, but we don't know what it is, like a birth date. Or it could be null because there isn't one, you know, like the name of your spouse or something, and you don't have a spouse, so that's not quite right to put a blank there because it's not like the name of your spouse is blank. It's like you don't even have one. So anyway, so null is a peculiar thing, and null kind of has its own you know, logic to it when you're doing ands and ors and so on. So you just have to pay attention to that. And when you're writing expressions like for a where clause, and you know that you're going to encounter some nulls, you want to, you know, account for that right in the where clause. You want to say and not null, or you know, so on, to exclude records that maybe have null values in certain fields. So that's what this is about. You pay attention to that. See, it's not, you know, it's not logical like everything else that we've learned. So this is select songs with null values. Okay, so here's an example of this. Okay, let's see. Let's see what happens when we just run this. Let's see what happens. Okay, so what are we supposed to do? Given SQL, the given SQL creates a song table, inserts some songs. Some values are null. A select statement selects songs that have a null artist value. So you're supposed to modify. Well, that's what this does. So yeah, okay, press the button. Modify the select statement. So to only select the songs that have a null title value. A null title value. This looks for an artist value as null, like this one and this one. But we want the title value. So I'm going to say, what is it? Title? Is this the one? Paste, run. And by the way, it looks like I already got the points for doing the other thing. But anyway, so yeah, here it is. Title. Great. Wonderful. All right. Refer to the, so you can go through these. What name is selected with each statement? This selects the name. So it's just something, just this from this whole table, whereas salary is null. Well, which one is salary null? It's just this one. So it looks like it's gonna just, this is what the output's gonna be. See, so there you go. So that should go in there, and you click check, then you get the points. Null and aggregate. Okay, some SQL statements also contain aggregate functions. The aggregate function operates on numeric values for multiple rows, including only rows with a where clause. So these are the aggregate functions. Okay, so it looks like they all ignore null values. Well, that's good. Makes sense. I would still put it in the where clause, but all right, so that's good. That's interesting. Mm-hmm. So what happens when you're doing salary plus bonus? Salary plus bonus must be, let me see this. Let's click through this one. Okay, 45. Oh, it's null. Okay, so that just ends up being null. That's what this is over here. So salary plus bonus is null. And for this one, oh, I see. Salary plus bonus is for the remaining rows is this. Okay, so this is just for the rows. And so that's, what's this side over here is, Mhm. Okay, well, I'm not sure what we're supposed to get out of that, but anyway, what is the result of the following statements? Max bonus, I would say it's this plus this plus this, which is I don't know, it's 55 plus 48 is 103 plus 3 is 106. 106,000. Bonus. Okay, I'm adding wrong. 3. No, it's not. Does anybody know what I'm doing wrong? Let's see. Am I adding wrong? I thought I could add that in my head. Oh, well, okay, I'm just going to click show answer. Okay, 50.
Max bonus.
Oh, thank you. I was thinking sum, of course, right? Great. So this one, it would be, I guess we'd be ignoring this one, and this one is null. Okay, right. So max ignores those rows, so it's just selects the largest amount. Oh, we're doing max again. I see. So it's the max amount of those. All right, great. Okay. Let's see, null logic. Oh, okay, so this is kind of what I was talking about null logic. In regular, okay, so this is true and true is true, true and false is false, true and null is null. So anyway, I usually don't like to get that deep into it. But all right, so what names are selected for the following query? So what are we learning about here? Oh, null logic. Oh, I see. So okay, so salary is greater than 3,000. And well, I'm just gonna, okay. Salary is greater than 3,000, or bonus is greater than 1,000. So wouldn't it be Lisa? Oh, it's not everybody.
It would it be Lisa because null and null is null? Oh,
For salary or bonus. Okay, but the salary is greater and it's or. So I guess it just ignores this. Well, it doesn't matter because it's or. Okay, let's do this one down here. Let's do this one here. Well, salary is greater than 3,000. So, oh, and bonus is greater than 1,000. Oh, so it's got to be just Sam's. No, it can be Sam or Maria. Yes. No. Okay. All right. Well, anyway, so make sure you go through these and make sure you got it squared away in your head. What time is it? Okay, we are on 2.3. Okay, I'll do one of these. Select ISO code from, oh, let me just start it. Select ISO code 2 from a country, from country table, where the area is not null. FR for France. FR. Because it is the ISO code 2 from the country table where the area is not null, and we're just, is just one of them. All the rest of them are null. Yeah. Okay. The next one would be select the min area from the country. So that would be not the sum, but the min. 6,900 is what I'm thinking. All right, so you can do the rest of those. Okay, primary and foreign keys. Primary key is a column or group of columns used to identify the row. So lots of times you'll just see an ID field, and all it is just some number, just some random looking number, which is what it is. It doesn't have any more meaning than that. And that is what makes sure that, and that's defined as the key, the primary key, and that's what makes sure that there's never going to be any redundant rows. Because even if you do put in a duplicate record, you know, for a person, and you put that person in twice, they would end up with 2 ID numbers, and so it would still be, you know, you of course want to have other checks to make sure, but no, you want to have something like that is just all it is just a number, because you're going to want to refer to that employee in all kinds of other places. And all you have to do is say, oh, the employee ID is 5384, and everything that goes along with Sam Snead, you know, you've sort of defined that. So this is one way of indicating that this is going to be the primary key. I guess in these examples it will be. And so here, often the primary key is used in the where clause. The name is not a good primary key because 2 people can have the same name. An employee can be added without a number. You can't add an employee without an ID value because then you're not going to have any way of. There's got to be something there. There's got to be a key value there. Also, though, you usually make it so the database itself just keeps track of the ID. If you're going to insert somebody new in there, you don't put anything for the ID. And the database will say, okay, the next number is this. Boom. All right. Feel free to sign off anytime you want to. And you cannot add a new employee with this number because there already is somebody with that number. Okay, sometimes you have a composite primary key. And so like, let's say you have a table called family, and you wanted to store the names of people in an employee's family. And so you may have the employee ID here, and then for however many family members the employee has, you have a second field which numbers them 1, 2, 3, 4, 5, and so on. And the combination of those 2 things make up the primary key. So it's a composite primary key. So just like that. All right, so then I guess you do something like this. All right. What is the primary key of phone number? Well, this is an example of they're all together have to be the primary key, because there's more than one. There can be more than one record with any single column, using any single column or any pair of columns. Okay, so just area code, there's two with the same area code, there's 2 with the same exchange, there's 2 with the same number. If you take a pair of them, there's duplicates. If you take this pair, there's duplicates. If you take area code and number, there's duplicates. All that's left, because there's no duplicate rows, all that's left is taking all of them, using all of them together as the composite primary key. So it'd be this one, I think. Yeah, okay. All right, so foreign keys are, it's a column in some table, and what is in that column is actually the key value for a record in another table. So it's the key value for a record in another table. So here, for example, we have a table called department, and in this table of there's going to be a manager for every department. There's going to be a manager, and so how do we indicate the manager? Well, the manager is going to be an employee, and so what we really want to do is put the key value for that person, that employee, in the employee table, because we don't want to mess anything up copying over stuff. Like if we just had the name here, we might put Lisa Ellison in there and spell Lisa wrong or something, or we might put the wrong salary. So that's the whole idea with databases, is we put the key value of another table here as a column in this table, and that is called a foreign key. So that's that. So make sure you understand that. Multiple foreign keys referring to the same primary. Okay, so yeah, sure, you can have this, where you have department staff, and you have a manager and an assistant, and the manager has the primary key, has a foreign key into the employee table as who the manager is, and the assistant field is a foreign key into that same employee table, you know, with the as a foreign key, the same primary key, two different foreign keys. You can even have this, where in the employee table, you may have who the manager is, and that manager is also an employee. So here in the employee table, you might have a manager column. And sure enough, you know, the manager column is a foreign key back into it itself, or it's a foreign key into a new instance of itself, a duplicate instance of itself, which can be renamed, which you would rename probably. And so it's just into the primary key. So anyway, so you can have that too. So this is how you'd, so anyway, so here's how you would use the composite primary key, dependent number, composites. All right, so make sure you understand this. Match the table with the special case. Foreign keys may be composite. Foreign keys may refer to a primary key in the same table. And you can figure out what the last one is. All right. Which department has the same manager and assistant? Whoa. I would say that it would be department, same manager. Which department has the same manager and assistant? There's no department that has the same manager and assistant. Nope. So I would say no department. Yeah. All right. So anyway, you can do the rest of them. Time 306. We're in 2.4. All right. See how are we doing here? You know, there's like 3 classes for this chapter, isn't there? Let's see. We are in chapter 2. Oh, this was last week. This is this week. Oh, there's one. Oh, but we're still okay. There's 2 class periods this week, so we're still going to be in this week, and we have next week also. It's great. All right, so let's keep moving here. So let's do this one. Let's do one of these. Let's see, click. I want a country name where the ISO code 2 is FJ. What is returned? FJ. Country name, Fiji. Fiji. Yes. Next. Based on the data in the country table, select the properties satisfied by the column continent pop rank. Rank. Let's see. They are not unique. Okay, what's the question? Based on select the property satisfied by the column kind pop. It's no, it's not unique. It's not no. It's not no. Definitely not no, because it looks like it's part of the primary key. It looks like continent and continent pop rank is a primary key. So it's a composite, I believe. So it's got to be not no. Let's see if I'm right. Oh. Set an answer for each input. I don't know. Try again. What is this? Oh, did I not do this or something? Oh, I didn't do that part. Oh, is that the problem? Can continent pop rank be a primary key of country table? No. It can be part of the primary key. Well, let's see what it says. Expect not null, minimal, no. Oh. All right, let's see. If I'm confused, some of you might be confused too. So I'm going to get this one right. Each correct answer is highlighted. It should be minimal, huh? What does it mean minimal? Well, anyway, let's try it again. Let's try this again. All right. Based on the data in the country table, select the properties satisfied by the column population. I don't see any of them being satisfied by the column, if I understand what satisfied means. So I'm going to see what. Well, no, I don't have to see what that. Let's see. So I'm not going to check anything. Can population be a primary key? No. Let's see what this says. Gee whiz, this is weird. Okay, so let me do a select on minimal. I'm not sure what they mean by minimal. How do I do that? Oh, is that what it means? Population is minimal since population is a single column? Minimal. Oh, oh, where is minimal? I'm going to go all the way to the top. And I'm going to see if I can search. How do I search? Oh, search or minimal. A candidate key is a simple or composite column that is unique, is minimal. And minimal. Minimal means all columns are necessary for uniqueness. Well, I'll be honest with you. I'm not quite sure what that means, but I'm gonna let's see. Where are we? We are in where were we anyway? This where we were? No, are we here? Can someone remind me where we are? Okay, well, anyway, so I think we were here. And I don't quite get, well, anyway, tell you what, I'm gonna have to learn what that is. Minimal.
Does that mean because it's not like a composite?
Yeah, I guess. I mean, I guess. Let's see, where was that? Was that in, it wasn't in
That would
Null.
have been primary foreign keys.
It was in here, okay. Yeah. Okay, well, anyway,
Down more.
that's the, I'm down. This is
It
it.
must be referential integrity then,
Yeah.
because it was after this.
Yeah, well, it could be the second. Yeah, right. Okay, well, anyway, okay, so let's just keep moving. You're gonna have to click. I'm gonna find out what it is. I'm gonna fix, because I remember this. So yeah. Okay, well, anyway, let's keep going. I will figure it out and tell you next time. All right, so it's about 3:15. I have what I'm searching for it on the tape. All right, so so we are referential integrity. Okay, so referential integrity has to do with the integrity of a reference. So if you have something in here, manager, and you're referring to employee, you can't have a number in here and not be an employee in here. Okay, so you know what that means is, like, let's say you're over here and you're going to delete, you're going to fire Lisa Ellison. So you have somebody in personnel that's all itchy and wants to fire people, and so goes in there and deletes out Lisa Ellison. Well, not so fast, because Lisa Ellison is still the manager of engineering, and you have to at least change that link. You have to find a new manager. You have to remove this reference. Okay, so just as what we're going to learn is that there's a couple of ways that we can enforce the rule. Okay, the rule is the rule. If there cannot be a number over here, there can be a null. There cannot be a number over here, and there not be a corresponding number over here in employee. Now, the ways that there could end up being a bad record in here, where we have a department with a manager and it's a number, and there's the person does not exist over here. Okay, is first of all, let's say we did just try to delete Lisa Ellison. Well, you can tell the database to do one of two things, because there's still a reference to Lisa Ellison. So what do you tell the database to do? Well, you can either tell it to delete all references to Lisa Ellison. In other words, if you delete Lisa Ellison and there's an engineer and you have this, well, then you end up deleting this record also. Well, of course, you don't want that in this case. Or you simply do not let the deletion take place. You say, sorry, you can't delete Lisa Ellison. There's still a reference to her, you know, in this other table. So you have to go over and take care of that first. So anyway, that's referential integrity. Here's an example. You can't have this. Partially null violates referential integrity. Here's one. It's not really one. Oh yeah, here. See, 0202. There is no 0202 here, so that's violated. So the database would just, okay, after you tell the database that this is a foreign key into this table, into here, after you tell it that, it'll also ask you, well, what do you want us to do? You know, what do you want me to do if there's like a violation? Well, you don't let it happen. Okay, so you create and come along, you're going to create a new department, you throw it in there, you put in some bogus number for a manager, and it'll just say, no, you can't do that, because first of all, you got to put, oh, you're going to put 0202, well, you got to put a employee over there that's 0202, or maybe it means something else, you know. So anyway, so that's what's match the violation type with the database change. Okay, so change the Maria Rodriguez's ID to, that would be updating a primary key. I'm not sure. I don't know, that is correct. Okay, so for updates, let's say you come along here and you decide, well, Lisa Ellison, she doesn't like 2538 because whatever. So you decide, okay, we'll give her a brand new one. We're at 77,000, so she can have 7,001. Okay, so you go in there and you make the 7,001. Well, what it'll do is it'll you can set it so it changes this to 7,001. And if you change this to 7,001, yeah, right, yeah. If you change this, then it'll automatically propagate back and change this. Or it'll tell you you can't do it because, but when you set up the relationship, you say which you want. All right, so that's referential integrity. All right, let's try this. See if there's anything else I don't know. So let's start. With restrict referential integrity, what happens if ISO code 2 of Burkina Faso is updated to XX? Can I start? Okay. What are my choices? ISO code 2 of this place is updated to XX. Yeah, right. And there is no XX down here. So what'll restrict? Okay, well, yeah, I guess it's update is rejected. So that's what I'm gonna say. They say restrict. Okay, it's rejected. Good, I was right. Next, with set null referential integrity, what happens if the code of Venezuela is updated to XX? Okay, so this is up. This is updated to XX. All right. Okay, so that's updated to XX. With set null referential integrity, what happens if the code of Venezuela is updated to XX? I don't know. I guess it's What happens to the code of Venezuela? Well, I'm just going to say it's updated to XX, even though I know these are numbers in the code XX. But what happens to the row in geography table? And it's set null. Okay, I guess it gets set to null. All right, let's see if this is right. All right, yeah. All right, what's next? Let's do another one. Oh, 323. Now let's keep moving here. What's next? Inner and outer joins. Okay. So joining is when you're taking advantage of the fact that there's this foreign key relationships, and you can create new tables or virtual tables by combining you create a single virtual table by combining two tables that are related together, and you pick which columns that you want out of each table, and they're tied together by the primary key foreign key relationship, and in doing that, that's called a join, where you're joining two tables together. And the different types of joins have to do with what do you do if there's not a match in the other table. Okay, you can either let's say you're joining a department with employee, and there's you're doing it by manager and ID, and what happens if in the merging or in the joining, there is a department that doesn't have a corresponding manager over here. Do we include that department, or do we not include that department? Or what happens if we have employees over here that aren't in the department table, and we're joining them together? Do we have nulls over here in the department table so we can include the employee, and we say, oh, here's the employee, and they are the manager of this null department, because they're not a manager of the department, so these fields are null. And so do we want the table to be that, or do we not want to include it? Well, that's the difference between left join, right join, inner join, outer join. So distinguishing identical column names. Here, the two column names are the same, the ones that we want to join. So in that case, oh, look here too, there's a department name and employee name, where we got these redundant column names when we're joining these two departments. Well, that's okay. You just prefix the column names with the table that they are a part of. See, just like that, okay? So here we're joining this way, and this is like a cross product kind of join. It's like you're just matching up every possible combination of department and employee. Well, there's 4 departments over here, and there's 3 employees over here. So every combination of those 2 records together, tables from those 2 records together, it's going to be 4 times 3 is 12. So you have these 12 tables, these 12 rows in this combined table. But there's a lot of them that don't make sense, because really we only want the matches where the IDs match up. And in fact, yeah, so it's only going to include the ones that the IDs match up, and that's fewer. Okay, it's going to be 1 for here, 1 for here, and a duplicate 1 for here. Okay, so Maria is going to appear twice, connected to marketing and sales, and Lisa is going to appear once, connected to engineering. And Sam's not going to appear at all, because he's not a head of any department. And it's up to you whether you want technical support to appear. There's no employee there, but if we were doing a left join, then this would be included, because we're taking the employee table and joining it with the left, with what's on the left. The join is that way to the left. If it's a plain old join, then we only include records that match up with something, so there's no null records. So in that case, technical support would not be included. If it's a right join, we would have Lisa there and Sam there and Maria there, and we'd have engineering there and sales and marketing, but we would not have technical support because there is no employee connected with that. And but you would have Sam Sneed, but it's just that there would be the department fields would be null. And that would be a right join. We're joining to the right. So anyway, so go through this and join the first thing. Okay, well, make sure you understand what they mean by this. Which columns? Okay, I guess we're getting towards the end here. Inner join, left join, right join, and full join. That's what I was kind of talking about. Okay, anyway, I got you said why not quite. Okay, full join. An outer join is any join that selects unmatched. Okay, so I see. It selects unmatched rows left to right, and full joins. Okay, and so an outer join is what you call it when you do include unmatched rows, and so any of these are going to can be outer joins. Okay, that's great. We've got some nulls here, so that's going to be. There's special cases. This equijoin. We're always going to be talking about where we're joining equal, where some column in one table is got to be equal to some column in another table, but it wouldn't have to be. It can be like greater than or less than, and so then the joins get more interesting. But we aren't going to really do anything with. We aren't going to really learn how to use those. Self joins, of course, is like the case where you have the employees and the manager, and you want to do a join for the employee. You want to make a table that's got the employees and their manager, and it's the same table, but you just So what you have to do is you have to use the same table, but you have to use aliases. So it's from this table, and we're going to call that table A. And then we're going to do an inner join with the same table, but this one we're going to call B, and then we say what the column matches are. It's going to be B of ID equals A of manager. Right. So that's a self join. Cross join is where you just combine the tables without comparing the columns, and so it's like a cross product type thing. All right, so it's 3:30. We'll start up again. Maybe I'll do this challenge activity just to get us started next time. So, and we'll get into view tables and normal forms and so on. So, are there any questions?
No.
All right.
Just whatever that minimal was. That's the only thing.
Yeah. Okay. All right. Minimal definition. Okay. Good. Thank you. So I will talk about that first next time. All right. See you next time.
All right. Thanks, Mike.
Thank you. Yeah.